All right, this is the video for section 9.4 notes, slide number 16. All right, so we're still using L'Hopital's rule here, and we are trying to use it to evaluate limits. All right, so first step in a limit is to evaluate. All right, so we are going to plug 0 in. So e to the 0 minus 0 minus 1 divided by cosine of 0 minus 1. All right, so e to the 0 is 1 minus 0 minus 1. So 1 minus 1, of course, is 0. All right, in the denominator, cosine of 0 is 1. So 1 minus 1 is, of course, 0. So remember, in order to use L'Hopital's rule, we must have the limit as the numerator, or sorry, as x approaches 0 of the numerator equals 0 and the limit as the denominator equals 0. So remember, we must make sure we state the limit as x approaches 0 of e to the x minus 1 equals 0, and the limit as x approaches 0 of cosine of 0, sorry, not, you have to say cosine of x minus 1, all right, and that also equals 0. And what must also be true, all right, e to the x minus 1 and cosine x minus 1 are continuous and differentiable at x equals 0. All right, so once that is true, then we can use L'Hopital's rule. So we're going to put an L in a circle there to indicate that we're using L'Hopital's rule. So limit as x approaches 0. So now we're going to take the derivative. All right, derivative of e to the x is e to the x minus the derivative of x, that's just minus 1, minus the derivative of 1 is 0, divided by, what's the derivative of cosine? That would be negative sine of x minus 1. All right, and so now I'm going to re-evaluate with x equals 0. So e to the 0 minus 1 divided by negative sine of 0 minus 1. So e to the 0 is 1 minus 1 is 0 divided by negative sine of 0. Sine of 0 is 0 minus 1. So we get 0 over negative 1, which is 0. So this limit is in fact equal to 0. All right. Next, all right, we have limit as x approaches infinity of 7x squared plus 4x over 9 minus 3x squared. All right, so we're going to evaluate 7 times infinity squared plus 4 times infinity. That is going to be an infinite value divided by 9 minus 3 times infinity. That would be negative infinity, right? And so what must we state? That the limit as x approaches infinity of 7x squared plus 4x equals infinity, and the limit as x approaches infinity of 9 minus 3x squared equals negative infinity, right? And then we also must state that 7x squared plus 4x and 9 minus 3x squared are continuous and differentiable as x approaches infinity. All right, and so now we can use L'Hopital's rule. All right, so limit as x approaches infinity. All right, so derivative of 7x squared plus 4x, that would be 14x plus 4, divided by 9 minus 3x squared, that would be derivative of 9 is 0, derivative of negative 3x squared is negative 6x. All right, so now here, when we reevaluate, we're going to get infinity over negative infinity once again, right? And so then, of course, we would need to once again state now that the limit as x approaches infinity of 14x plus 4 equals infinity, and the limit as x approaches infinity of negative 6x is negative infinity. And once again, 14x plus 4 and negative 6x are continuous and differentiable as x approaches infinity. And so then we would use L'Hopital's rule again, and we can say the limit as x approaches infinity of, all right, so derivative of 14x plus 4 is 14, divided by derivative of negative 6x is negative 6. And so this just is negative 14 over 6, or negative 7/3, right? And so that gives us that value. All right. Last one. All right, so let's take a look at this one. So once again, we want to evaluate initially. So we have 1 times the natural log of 1 minus 1 plus 1 divided by 1 minus 1 times the natural log of 1. All right, so 1 times the natural log of 1. Natural log of 1 is 0. So I have 0 minus 1 plus 1. And then in the denominator, 1 minus 1 is, of course, 0 times the natural log of 1, which is also 0. And so I get 0 divided by 0, right? And so what do we want to state? We want to state that the limit as x approaches 1 of x natural log of x minus x plus 1, sorry, plus 1 equals 0, and the limit as x approaches 1 of the denominator x minus 1 times the natural log of x, that also equals 0, right? So we're looking to get 0 over 0, all right? And then, of course, we need to state x natural log of x minus x plus 1 and x minus 1 times the natural log of 1, sorry, times the natural log of x are continuous and differentiable at x equals 1. All right, and so now we can use L'Hopital's rule. All right, so limit as x approaches 1. All right, so derivative of x natural log of x. So this is a product, right? So I have to take the derivative of x, or sorry, x times the derivative of natural log of x, which is 1 over x, plus the natural log of x times the derivative of x, which is 1, minus the derivative of x, which is 1, plus the derivative of 1, which is 0. All right, then denominator, once again, product rule. So I have x minus 1 times the derivative of the natural log of x, which is 1 over x, plus the natural log of x times the derivative of x minus 1, which is 1. All right, and so now I'm going to, well, I can simplify or evaluate or whatever. So I have x over x, that's just 1. All right, so I have 1 plus the natural log of x, which is natural log of 1, and then minus 1. All right, all divided by, once again, 1 minus 1 times 1, right, 1 over 1, and then plus the natural log of 1. All right, so natural log of 1 is 0, so 1 minus 1 is 0, divided by 1 minus 1 times 1, right? So that would be 0 times 1 plus the natural log of 1, which is 0. So 0 plus 0 is 0. So once again, 0 over 0. So then once again, yes, I would need to redo this, right? And so now we're going to, restate, of course. Okay, so this the 1 plus the natural log of x minus 1. Well, that's just the natural log of x, right? So we would say the natural log of x is the limit as x approaches 1 of the natural log of x is 0. And this thing down here, limit as x approaches 1 is 0, and they're both continuous and differentiable. So then we want to use L'Hopital's rule again, limit as x approaches 1. Now, remember, this top part is 1 minus 1, so those actually just subtract out. So we're really just natural log of x, which derivative is 1 over x divided by. All right, so now what do we have here? We've got this thing, right? Which if you distribute is just 1 minus 1 over x. So derivative of 1 is 0, and then minus 1 over x, that's negative 1x to the negative first. So that would be, let's see, I bring the negative in front. So that'd be positive 1x to the negative second plus the natural log of x. So derivative of that is 1 over x. All right, and so now we're going to plug in 1. So we get 1 over 1 minus, this would be 1 over 1 squared. So that's 1 plus 1 over 1, which is 1. And so I end up with 1 over 1 plus 1 over 1 plus 1. So that is going to give us 1 half. All right. And so 1 half is our answer. So now I understand that this can be tedious and annoying, but the big keys are taking the derivative of the numerator and denominator separately and then re-evaluating in order to use L'Hopital's rule to evaluate a limit.